I'm going to talk a bit about building the new WeTransfer mobile application. I'm just curious, how much of here have installed the current WeTransfer application? Okay, that's not much. How much of you do know WeTransfer? Okay, that's better. Let's keep it like that. All right, so hopefully this new mobile app will be installed on your mobile phones soon. You can actually install the test flight application downstairs with an iPad, register yourself, and you'll be set up. Yeah? Yes, all right, cool. So I was asking myself what's my goal for this presentation, and basically I want to give you insights in how we work at WeTransfer, how we build our mobile application. And I'm doing that in a few steps. What did we build? How did we build? What did we learn? Those are the topics I'm going to talk about in a bit. So what did we build? Basically, this is what we built. And the reason I'm showing these pictures is because we name our frameworks like animals. So we have coyote, we have rabbit, we have okapi, and we've got ocarina, which is, I thought it was a submarine from Zelda, but I learned today that it's an instrument. Okay, I'm not a gamer. Sorry for that. I'm disappointing a lot of people here right now. But yeah, that's basically our naming for frameworks. But if you look to the mobile application we've built, then this is our new WeTransfer mobile application. We have several ways of describing the application, which is sometimes hard to tell to people. But basically, how I see it, it's like more a visual representation of your transfers you're sending from anywhere to anywhere. So you can collect items with all different kind of content and send it to whoever you want. So the flow for adding content. You have a website you like, you open the share extension, and you can add the content to your collections. And this is basically an example of adding content to the app. If we go more in depth, and we have the main application, and we have a share extension, which are all built on several frameworks we've built ourselves. And we have several dependencies, like Instabug for bug reporting. We didn't want to build ourselves. And I did a talk last year in November, and I remember myself saying, like, yeah, you should use dependencies because it saves you a lot of time and it's way better. And when I was making this presentation, I realized that I was going to say we try to use as less dependencies as possible. And that's funny, but I think it's really good to have the code base contained in your own environment, and you can just fix whatever you want without having trouble with pull requests from other repos. And well, you can basically adjust anything you want quite easily. Downside is it takes a lot more time, and I know that not everybody has the time to build all frameworks yourself. But we did, and if we dive into those frameworks, wow, that yellow color is way different from my yellow color. The contrast is quite okay, I guess. We've got Rabbit, which is basically our core framework. It contains all networking logic, all business logic we need for our app, and we can reuse it for the share extension as well. And we've got Okapi, which is basically our tracking framework, where we use Firebase and Fabric to collect all the data we need. So if we dive into that, Rabbit we used for content adding, content syncing with the backend, content uploading, all those tasks. And Okapi is basically all things related to tracking, but also to A/B testing, where we use Firebase remote config to easily generate A/B testing. But how do we work? Well, I was on a course for leadership, and I learned about the this sentence called sharpen the saw, which basically means invest time in making things easier for future purposes. And Sam was making an issue on GitHub where he was saying, Antoine told me to sharpen the knife. He was joking about it a bit, but we were quite serious about this because we wanted to invest a bit of time. Feel free to take a place. Cool. All right. We wanted to invest some time in making sure our setup was solid, which would save us time in the future. So if you take Steve Covey's meaning of sharpen the saw, and it basically means if you cut wood and your blade is not sharpened, it will take a lot more time. So if you invest in sharpen the blade, it will go way faster. And if you take a look into how that works for development, it's basically set up your tests, make sure you don't waste any time for reviewing PRs with, hey, you should use weak self instead of unknown self. That's a sentence we heard a lot. Or you have to add documentation to this public property because it's in the framework. That's time you can save for yourself to invest in reviewing the structure of the PR instead. So if you dive into continuous integration, we've set up our CI with tools like Danger and SwiftLint. When I was making this presentation, I was curious about how many people do know Danger. So how many of you use Danger? I now know how much know. Okay. Well, not a lot. For us, Danger saves a lot of time in automatically reviewing the PRs, as you can combine GitHub, GitLab, or Bitbucket together with SwiftLint. So if we dive into Danger, it basically gets all your files, the modified files, and walks through it. And you can add several plugins to make it much more valuable. We use, for example, Xcov, which gives us a review of code coverage. So we know the files were changed, how much code coverage it has. But it also warns when no tests are written for lines more than 20, for example. And it will report it like this. This is an example from Danger itself. And you've got several ways of reporting warnings or errors, and you can basically say CI has to fail when an error is thrown. So we don't even have to start reviewing a PR if errors are there. So that saves a lot of time, and sometimes you don't even have a lot of time left, so you can review it quite fast. And last month we open sourced our config, which is available on the Danger website. So if you dive into Danger, you can look up our config file, and it had a lot of custom rules we've built during the time. I was saying a lot we have to use final class, something I like, which I really want to have throughout the code. So we basically check the line and see if there's a class name in it, and if there's no final in it, then we warn, hey, you have to use final, and so on. We do the same with unknown and weak, where we think that weak self is always safer to use, as you are sure that you will not retain any objects in your closures, for example. So this is an example of the config file, and it's Ruby, and it's really easy to just create your own warnings and errors based on the lines in the file. You don't even have to learn Ruby for this to set it up. So I would say really look into Danger and see if it works out for you. But if you don't have the time to create the config file yourself, you can use basic plugins. For example, changelog for framework, open source frameworks. Moya used it a lot, and you can basically require a PR to have a changelog added. So if somebody adds a PR for your open source framework, you want the changelog to be updated, you can use that plugin inside Danger, which warns automatically. But also code coverage or SwiftLint with inline reporting about SwiftLint warnings. And How many of you know Swiftlint? I think more, right? How many of you use it? Okay, that's really good. You can automate it inside your process, and most of the time you do it automatically because you run it inside your project. But if you forget to fix some warnings, you get an automatically report of Swiftlint inside the danger report on GitHub. And it's really easy to set it up. You can even use multiple Swiftlint files in subdirectories. For example, we use force wrapping inside our tests because sometimes it's just obviously that it has to be there and else the test can fail. That's fine, that's no problem. But you define your rule set inside a config file where you can also add custom rules. For example, we've got a custom rules for a set for prints. We don't want people to use print in our code. We use OSLog, so we have to warn people. I'm a bit scared of the screen a bit. So yeah, you define your custom rules and make sure the code is solid and you don't have to waste any time in reporting silly warnings which are made often. This is the lines you see in the danger file. You don't need more than this to enable Swiftlint together with danger. And it will automatically report it inside a summary on GitHub. I found these two blog posts very handy if you want to start using Swiftlint together with danger. I think the slides will be up after the presentation, so you can look back. Yeah, but those are really easy, handy tools to get started. Blog posts. So, in other words, set up your environment, make sure it's solid before you start building the app. We did a 2 weeks preparation before we actually dived into the real big things in the applications, and we've made sure the CI was set up and it all worked. But we also did a preparation for testing, and we wanted to make sure that we can test offline, and it was all set up for writing tests in the future. So what we think is important, if you do requests and those are not offline, then it takes time. So CI will take a longer time to review your PRs. So if you can improve that by making mocking requests, which basically means that you don't go out of the app, you can basically use the test without any internet. For example, in the train, if you have bad internet connection, you can also use it. So it saves a lot of time. So we've built a tool for that, where I will dive into later on. But we set up CI. We set up CI together with Danger and Swiftlint, and we report our testing coverage. And it's always a funny thing when you discuss how much coverage does your project need to have, and it's a discussion worth. But you will never get the 100% if you use guards, for example. Those are most of the time things you will not often test. But you can set a minimum target of code coverage, which will also mean that if you get below the target, then CI will automatically fail. But we were also building a share extension. And before we really built it, we wanted to investigate how we could test the share extension, because most of the time with UI tests, you can't go out of your app. We figured it out, and it was actually possible to launch an app outside of your main application and basically start doing all the things you do with your own main app as well. Last WWDC, they announced multi-app testing, which is basically the same as this. But if you want to test it right now with Xcode 8, you can use the line of code I showed on the last slide to really easily launch a different app, for example Safari, and test your share extension. What we do is open the main app afterwards and check if the content which is added actually exists. So we are sure the share extension did work. So offline testing. We've built our own framework for mocking, and We wanted to keep it really simple. So what we basically did is we've created an URL protocol which catches all the URL requests, checks if a mock is registered, and if not, the request will fail and the test will automatically fail as well. And registering a protocol is really easy. It works with all requests you do yourself with URL session, and you can also register it with custom URL sessions. For example, what we do here for Ocarina requests. And if you look at how the flow works, a request starts, the URL protocol catches the request, checks if a mock exists. If not, a fatal error will throw. Otherwise, the mocked data will be returned. Mock data can exist from image files or data files to JSON for JSON requests. Registering a mock is quite easy. You basically define what you want to return, and you can also define for multiple types of requests what you want to return. For example, for a get and a head request. But you can also say I want to respond with a 400, 400 if you want to test a failing of your test. In our Rabbit framework, we've built our own API provider, and we made an extension to make it really easy to mock our endpoint requests. But it basically gives you an idea that it's possible to make a mock for all types of URLs. And it looks like this, where we give our endpoint, which is build up the URL, and it will return the data we want for making offline requests. And I realized that I had to say before, but we're going to open source it soon. And hopefully it's very useful for you guys as well. It's a really small framework, but it makes it really easy to mock your requests and make your tests offline.
Can I ask a question?
Yeah, sure.
The project I'm working on, I'm not only checking if what gets returned or mocked gets handled properly, but also if my requests are what I expect it to be. Do you also test that or not?
What we do is we make mocked requests so we know exactly what will be returned.
Right.
So we
testing if the request is actually the correct URL, the correct body, the correct parameters, the correct headers.
Well, we set up the mocks ourselves, so basically that's something where it can be followed. But we test the end result based on the mocked request. So if the end result does not match, then basically our mocked request will not work as well, or did not work.
Yeah, but if you have an extra header in there, you will not catch it.
No, but we can test with the response headers to see if the header is in there, but the header comes from the mock data.
Yeah, but I'm talking about the request.
So
the
request headers.
Yes.
Yeah.
And even the request body, and that's a little tricky to do with your real protocol.
We've got some custom headers set up from our API provider, but we test the API provider separately, and the setup of the request and the build-up of the URL with the headers in there, we test that separately from the mocking.
Right.
So we do test that, but in a separate process. Okay. So open sourcing. Open sourcing is very important for us. We try to develop with open sourcing in mind, and what we mean with that is set up your project modular, make it reusable, and test it immediately. Which basically means you can open source some parts of your code afterwards automatically if you think it's valuable for other users as well. And for us it resulted in quite a list of frameworks. We worked together with Awkward, and Awkward built some frameworks that way, and we did some frameworks ourselves as well, where the mocker will come soon, very soon. And I will dive into those frameworks a bit. One of those is open sourced actually today, and it was picked up quite fast. But it's basically a really simple framework to post UI notifications inside your app. And we try to develop the same way Apple is developing their frameworks. So it looks quite familiar to the user notifications framework, which makes it really easy to adapt and use in your applications. In our app, you can add several types of content. for example, web content, which is really a special type of content because you don't really get an image from the URL, which is done by Ocarina. It does requests and it parses the images from the OG text, which you can use as a preview image for web content. You can also get more metadata of an URL. We've got Tracker, which is a wrapper around several service layers for tracking. This makes it really easy to opt in or opt out tracking layers. And we use it to track through one entrance and pass it through to Fabric and to Firebase. And last but not least is Tatsi. If you want to know the meaning of the name, you can look it up in the repo. There's a description about it. But it's basically the same as I said before. It's built up like Apple wants to build up their frameworks, and it's a really simple way of using an image picker, but then with multiple image select or multiple video select. So open sourcing, we think it's really nice to open source to the community, but it can also be really easy without having to use more of your own development time with the right mindset. So I want to encourage you to do that as well and check if you can build in a certain way that some parts of your app are really easy to open source. For us, it was only one day of making a setup and open source UI notifications because we had it all like modular setup. So it was basically copy pasted to a framework, and most of the time was setting up CocoaPods, setting up CI inside the new repo. So it can be quite easy. So as a conclusion, set up your environment before you start really building your app. Make sure your testing environment is set up and think with open sourcing in mind. And before I go to the last slide, I had a discussion with my designer and he said I had to put a Giphy on the end. And you will watch this back, so I know you will hear this. But yeah, this is the way we build apps, and if you have any questions left afterwards or now, feel free to ping me or ask me right now. Thanks.
As you said in the beginning that you want to have as less dependencies as possible, but
yeah.
Do you include your own frameworks as a dependency now, or do you still use the code base?
Yeah, we use them as our own dependency right now. I think I know why you are asking this, because yeah, the more frameworks you use in your app, the more startup time you will have. I think that's the question, right? So yeah, we want to use our own code because we don't know that our framework is still working. So right now we're doing it that way, and hopefully with Xcode 9 and the new build processing it will be better.
Yeah. Are you missing reactive programming?
So this is an interesting topic because I did a presentation about functional reactive programming last year, and it's so good you should use it. And I yeah, I've got some conversations with my colleague Sam about this, and I think last month I said to him like I'm not even missing it anymore because.
Why do you hate yourself so much?
Well, I had some moments that I was trying to build my own functional reactive programming example in, and then I got comments in the pull request. Why are you doing it that hard? You can just do it like this. And then I started to realize that you don't really need it. And it makes debugging a lot of easier as well, but I'm like, I still love it. Okay.
Oops.
Yeah.
So then delegates or closures?
Delegates or closures? Delegates.
What did you add?
What we added?
Yeah, why didn't you use one app?
Well, the default UI image picker didn't enable to select multiple files at once, and this one looks native as well, but we can also access all the albums, the private albums, all the things we needed in the end. If it's possible with the default UI image picker, please tell me. And yeah.
So from what I understood is you guys rewrote actually the whole app in Swift, right?
Yeah.
How did you manage to convince whoever is running the decision here to rewrite, or basically, I don't know how much time you spent, but rewrite the whole application, results are the same, they won't see it.
Yeah, that's our thing, right? To manage, yeah. Well, I actually started here last March, and it was already fast.
Oh, okay.
So Sam is here as well. You can ask him about that. But if you see the current application, and it's not really the same as what we are building right now. It's quite different. So that makes it really easy to make that decision, especially because you're more feature-proof. So I guess when you're doing quite a big redesign, what I did last year with Bioradar, then you have something to sell to the people who have to make the decision. But yeah, it takes more time. Yeah.
What kind of architecture did you do for the app? Like is it Viper or MVVM?
No, it's MVVM and without functional React programmer. So sometimes, yeah, sometimes it's hard. But we had a meeting I think 3 months ago, and we started to discuss how we wanted to use MVVM, and we set up some rules we use for that, and it works out quite well. But you use delegates for that.
But you have no map or flat map?
We do that with functional programming from Swift,
Okay.
which works in most cases, yeah, but not with value binding. That's something else. Yeah.
As most of the frameworks are standalone repos, when you need some new feature, how do you do it? Like you first release it or just do it locally? Because most of them are in, I think, GitHub open source, will be open source soon. So you first push the branch and then use that branch as a CocoaHead dependency.
Well, that's interesting as well. We don't use any package managers, so no CocoaPods, or we only use submodules. But what we do, you mean what we do before we decide to open source it, or?
Yeah, my question was that during the development, let's say you need one more feature in one of the frameworks. So first you implement it, right?
Mm-hmm.
How do you in CocoaPods, for instance, you need to either give new version or just direct a branch?
Well, if it's not a repo we own, then we make a fork, which we can use as a submodule for our project right now, which makes it really easy to adjust. And if we wanted to have it like in the main application or in the main framework, then we make a pull request for that. We take time for that. Yeah. Well, right now we are developing our own frameworks quite a lot, and we're changing a lot in a short time. And when we use a package manager for our own local frameworks as well, we need to add versioning. And it can be quite fast, but especially in the beginning when you change a lot in your frameworks, you don't want to release a new version each time. And we're almost at a point that we are going to start looking into the package manager to use it, because we want to use it in the end. But for now, a submodule was easy. Yeah.
How are you keeping track of the submodule versions between your different branches on the main product? Are you like tying them to branches? Or?
Well, we've got mainly changes based in Coyote and Rabbit. Those are the two we develop in a lot. And we've got a GitHub label Rabbit related, which marks it like, hey, if you merge this one in, then you also have to merge the Rabbit one in. So yeah, that's how we have to deal with that. In the end, we want to make versioning and make a separate PR in Coyote, like this PR implements version 1.2 from Rabbit, for example. Yeah. Any questions left? No? All right. Then if you have any questions later on, feel free to ask me. We will have a small break right now, downstairs again, and then we go back for the next presentation. Thanks.